All right, going on to another test from Math 1108, Chapter 2. Now, I think you'll find that lots of stuff from your Chapter 2 work in Math 1108 is right from our Math 1103 course, which was our Chapter 3, in which we worked with graphing, and you'll see that as we go through these items. So the first thing they're asked is to see if this ordered pair is a solution for this equation. And again, throughout this, we'll be looking for strategy. So, 3, and our x value is 3, plus y is 4, and does that equal 13? Well, we have 9 plus 4 equals 13, and it does. So the answer is yes. Now, since this test is multiple choice, they give you 4 graphs here to choose from. But again, you want to have a method for doing this. So this is not in any particular form. I would suggest you put it in, let's say, standard form, where we're going to transpose the 2y, negative 2y to the other side, where it becomes a positive 2y. The negative x is there already. So all I'm doing is taking this term, moving it to the other side, and it becomes the opposite sign. We transposed it. So now this is in standard form, and one of the techniques we said, when something is in standard form, for graphing it, is to make an x and y intercept t-chart. And you'll see why in just a moment. Now, if x is 0, this is a 0 here, 2y equals a negative 6. You're going to divide both sides by 2, so you get y is a negative 3. Now, if y is 0, this y is 0, you have a negative x equals a negative 6. Divide both sides by a negative 1, and you get x equals 6. So you now have, in a sense, and if we were to graph this, the graphs are already there. You're going to graph the y-intercept. This is the y-intercept here, 0, comma, negative 3, which is right about there. And this is 6, comma, 0, which is right about there. And then if you took a line and put it through there, and then notice it happens to be right here. So this graph is the representation of this equation, and there's an infinite number of points along this line. Now right here is your x-intercept, which is this value, and right here is your y-intercept, which is this value. But again, all they asked here is for you to graph this. Now, another way of doing this would have been, if it's in this position, take this term, bring it over to the other side, and we get 2y equals x minus 6. Now we divide everything by 2, and we end up with y, a positive y, equals 1/2 x minus 3. Now it's in slope-intercept form. Y equals mx plus b, where b is your y-intercept, which is right there. And your slope is 1 over 2. These are y units, these are x units. So you go over 2 up 1, right there. Over 2 up 1, right there. Over 2 up 1, right there. So in this case, we found the intercepts, and in this case, we just used the y-intercept and then applied the slope to it, and we get the same results. Okay, a little background. Now, in this example, they're asking us from the graph itself, what are the intercepts, the x and the y? Well, remember, when we write the y-intercept in its formal way, it's 0, b, where b is the y-intercept. And the x-intercept is a, 0, where a is the x-intercept. Now, when we look at it down here in the answers, they're not asking in this formal way. That's where you need to be careful of what they're asking. They just want to know what B is, just want to know what A is. So, for the x-intercept, what is A going to be? Well, A, -3, right there. And what is your y-intercept? It's going to be a -1. So, pick out the answer. Letter D. Now, normally I would have expected them to ask in its formal way, but again, you need to, through your practice and quiz me, know the form they are expecting you to give the answer. Now, for number 4, and keep in mind that on occasion you will be pausing the tape, I would again suggest for this that you would do an x and y intercept t-chart, where this will be your y-intercept and this will be your x-intercept, where this value would be b and this value would be a. So the equation is here. If x is 0, y is 6. If y is 0, this is 0. We're going to divide both sides by 3. This is 2. So, and again, all they're interested in is this and this, not in its formal way, and that is letter C. Now in number 4, I'll raise it up so we can see it just a little bit. Actually, number 5. They say the height of an object, approximately how high will the object be after 4 seconds? Well, again, time is usually along the x-axis, which they're indicating as t, and the y-axis they're indicating it here as height, amount. At 4 seconds, it's going to be right there, which is letter A. And an interesting thing with multiple choice, it does give you a flavor of what the answers would be like. Again, through your practice and quiz me, you should be familiar with that. Now, in our lessons of this section, they do give us graphing of radicals. So, for instance, the typical graph of, let's say, y, the function of y, is the square root of x. Now, when you graph that, it looks like so. So, notice this is like so, and this is like so. The ones on the bottom go the opposite direction. But if there were a negative there, then it would go the opposite direction. But again, you're asked to graph this one, but not this. But now extend it so it's plus 5. Now this has to do with the shifting or translation of this. Now, when you have a number along with the x under the radical sign, what does it do to this particular graph? Does it move it 5 units this way, like this one? Or does it move it 5 units this way as a negative? Well, the answer, and you should know this just from memory, that it moves it opposite direction to the sign that's here. So if this is a positive, it's going to shift it to the left to a negative 5. So B, or this graph, is the answer to this one. Now, chances are in your test that you'll have online, they will give you multiple choice and you have to pick out the one. But you needed to know that when it's a +5, it shifts it to the left. Now, if this were a -5 here, it would have been this one. And hopefully in class they went over the rules for that. Okay, now on this next one, and again, I'm not sure what calculator you're going to be able to use, but here we have an equation or a function that is to the third power. So here we're asked to identify what will be your coefficient of x to the third, which is your a value, and that is going to be a 1. Here your b value for this is a -4. Your c value is a -49. And your d value for this is 196. Now I put these values into the calculator, and this is what pops up. Now, if you had a graphing calculator and you said to graph this, an interesting thing would occur. And I'm just sketching this, that it would go through your x-axis at -7, at 4, and at a +7. And in a sense, we often refer to this as finding the zeros. That is, when y is a 0, which is right there, the y value is 0, you're finding what x values would be. And that's what they're asking here. And remember, we could substitute the letter y for function. Y equals 0. What are your x values? And that is finding the zeros. Okay. Now, in this next one, we're asked to find the slope. So we have the origin as one point, and we have this other point. So the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it's going to be -5 minus 0 over -5 minus 0 equals a +1. So this is just -5. -5 is a +1. So our slope for these points, this line, is 1. Now in this next one, here we're giving a formula in standard form, and they want us to find the slope and the y-intercept. Well, this is one we had in Math 1103. We want to solve for y, because by solving for y, we then put it in what is called slope-intercept, where there is your slope and there is your y-intercept. So let's do that. We have 4y. I'm going to transpose this to the other side. I get a negative 3x plus 14. Now I'm going to divide everything by 4. These cancel out, and I now have my slope and my y-intercept. And that is letter D. Slope is a negative 3/4, and my y-intercept, again I had to reduce here, I forgot to do that, but do reduce, so 7/2, yes. Again, when it comes out in its position, what's in the B is your y-intercept, but you should reduce it. Again, I'd give partial credit for that. MATLAB would count it wrong, but you had the idea. Alright, so as we look at a line in which it starts high, and as it goes to the right goes down, this is negative slope. So the answer to this is B. If it starts low, and then as you go to the right goes up, this is positive slope. If you have a horizontal line, and the equation of this would be like y equals b. Here the slope is 0. And if you have a vertical line in which the equation would be x equals a, this is your undefined. Vertical lines, undefined slope. Horizontal lines, 0 slope. Starts low, goes up, positive slope. Starts high, goes down, negative slope. So a little review here. Now, in this example, they're asking you to, if you had this equation in slope-intercept form, how would you graph it? And which graph would it match up to? Well, here are y-intercept, and this is y equals mx plus b. We always plot our y-intercept first, which is a 6. Now our slope is 5 over 1, so you go over 1, up 5. Now that's the way I usually graph them. Another way to graph this is to go down and then over 1, which is right there. So your graph of this, and then of course in MATLAB you will have to do the graphing yourself, where you'd put a dot on your y-intercept, and then chances are it would go up to 10 usually. So you would go over 1, up 1, it would make this graph. The other way to do it is go down 5 and then over 1 this way. But you want it to be a positive slope, starting low and going up. Now, for these, you want a strategy to figure it out. So we want to know whether these lines are parallel, perpendicular, or neither. Again, a topic we covered in an earlier class. Well, we had said that the best way to compare when they're asking for this is to solve for y. So I'm going to solve that first equation for y. For y, transpose this, equals a negative 12x plus 16. Now divide everything by 4, and I get y equals a negative 3x plus 4. Alright, now I'm going to do this one. Now, again, we can leave it that way. So we have a negative 8y equals a negative 24 when I transpose that, plus 32. So my negative 8y, I'm transposing that. Okay, now I'm going to divide everything by negative 8. And I get a positive y now equals a positive 3x and a negative 4. Now, what we do is we compare our slopes. So this equation, the slope is 3. This equation, the slope is negative 3. Now, are the slopes the same? No. So the lines could not be parallel because the y-intercepts are different. Now, how about could they be perpendicular? Well, the rule is if we multiply the first slope by the second slope and we get a negative 1, then the lines are perpendicular. But here, when we multiply the slopes, we get a negative 9. So they're not perpendicular. So for this one, it is neither. Now this was a little tricky because some of you might say, oh, look, these numbers are opposites. But we said the rule was if it were like, say, a 2, it would need to be multiplied by the reciprocal of the opposite sign. So that would give you a negative 1. But that doesn't happen here. So a little tricky. Now for number 13, this is something we did in an earlier course where we have 2 points and we want to find an equation. Well, the first thing we had to do is find what is the slope of this line. So negative 6 minus 1, which is what I have here, and then 0 minus a minus 8, which will make this a plus 8. So this is going to be a slope of a negative 7 over 8. Now, once we have that, we can then put our slope into the point slope form, which is a negative 7/8 times x, and we're going to use, let's say, this point here, where x is 0, and then here our y value is a negative 6, so it goes y minus is in the formula, a negative 6 makes it a positive 6. Okay, now since this is a negative 0 here, theoretically we can get rid of this part here and just put a line there. Now we want to put it in standard form, and standard form has no fractions. So I would strongly suggest that you get rid of the fractions by multiplying everything by the lowest common denominator, which is 8. And here the 8's just cancel out. So now we have 8y plus 48 equals a negative 7x. Now, we're still not in standard form. We have to take this term, move it to this side where it changes its sign and becomes 7x, negative 7x on this side positive. Just copy our 8y and then transpose this to the other side where it becomes a negative 48. Now here they're adding an extra level of challenge because no equation like that looks like this. But if I multiplied every term by a -1, it would make this a negative, this a negative, and this a positive. And now we have an answer. Now it's strange because often I would tell students they don't like to have this a term here as a negative. But again, this is the answer I would get, and I think would be preferred as it originally was. But again, since you're using multiple choice, that's the answer. But again, putting your work, and if it doesn't quite agree with what the math lab is looking for, if I were the teacher, I would give you credit for finding the slope, for knowing this formula, and so that's where the teacher is looking at your blue sheet carefully. Now in number 14, they're asking you to find an equation of a line that's going to be parallel to this equation, but goes through this particular point. So what you have to do from this equation that's in standard form is find the slope. So we transpose the -3x to the other side, divide by 4. I now have my slope. So I'm going to put this information into that point slope form, where I get y minus 4 equals my slope times x minus, now it's minus a -2, so this becomes a +2. And again, they want it in standard form, so I'm going to multiply everything by my common denominator here, 4, to get rid of my fractions. So these just cancel out. So I now get 4y from here minus 16 equals 3x plus 6. So now I'm just going to take this term, transpose it, so I get a -3x plus 4y. I'm taking this term, transpose it to this side. Now I'm going to take my -16, transpose it to that side, and get a plus 22. So there's my answer. So I found the slope by putting it in slope-intercept form. Then I use the point slope form to find out what the equation would be, and I then put it in standard form, getting rid of my fractions. So the answer, letter C, which is kind of obliterated a little bit here. Let's check it out here. Yes, there it is right there. All right, now number 15 is a little bit of a challenge. And keep in mind, I did work these out on paper ahead of time, so I knew what I was talking about. So in one U.S. town, consumption of beef, which will be B, can be estimated by the formula. Let's write it up here. B equals a -1/3 T plus 21. It's kind of cut off there a little bit. Where T is the number of years since 1975. Estimate the beef consumption in the year 1995. So this test was made a while back, I guess. But that's okay. Now, how many years since 75 to 95? And if you got 20, that is correct. So t is 20. This t is going to be 20. So through the magic of an eraser, I'm going to put a 20 there. So, what are they asking here? So I have a negative 1/3 20, so this is going to be a negative 20 over 3. I'm just multiplying that, plus 21. Well, what is this here? This is, if I convert it to like a number, 3 goes into there 6 times. So this is like 6 2/3 that I have to subtract from that. Now, you could put this in your calculator and figure it out too. So I'm going to make this a 20 here, and I'm going to borrow one and make this 3/3. Okay, so now I can subtract 2/3 from 3/3 and get 1/3. And I can subtract 6 from that and get 14. So 14 1/3 here. Ooh, not giving us thirds, so it looks like the answer here is B. That's the closest to it. So this was more of an arithmetic problem, I guess, than algebra, but understanding how to use the formula, and that it was a little tricky that this 21 was on the next line. All right. So this isn't too long. I did some of the work. I read this over, and again, you can pause it to read it carefully, because these are applications. So we have grams of acid and time, grams of acid and time. I can set up ordered pairs. Now I could use these ordered pairs to find the slope. So the slope of this relationship is 4/17. Now then I can use either of these points to write the point slope form. So y minus 20 equals my slope 4/17 times x minus 36. Now I'm going to multiply everything by 17. And then here the 17s just cancel out. So I'm going to multiply that through. So I get 17y minus 340, 4x minus this. So as you probably imagine, I'm going to take this term, transpose it, this term, transpose it, add it, and I will negative 4x plus 17y equals 196, which is letter C. Now again, it took me time to do this. I had to use my calculator, I had to know the formulas, but I wanted you to see the process. Okay, let's go on. And we're looking at this next one, where again it's something very similar, where we have linear functions for this first year. Looks like this one right down here. And for the third year. Now, this isn't super straight line, but we can approximate. And then we're going to use this function once we find out what the equation is to predict what will happen in the year 2011. So our x will be from the year 2000 to to 2011 is going to be 11. That'll be our x value. So let's put this into a formula where we use this to find the slope and then develop an equation. So we'll take it in steps. We're going to use this to find the slope. So 53,000 minus 46,000, 3 minus 1, gives us 7,000 divided by 2, gives us this for our slope. That we'll put in the point slope form. And it's y minus, I chose these points, and this for my x. So that's where we are. So we'll clear parentheses. Y minus 46,000 equals 3,500x minus 3,500. Now we're going to, since we want it in slope-intercept form, we have a y here all by itself. We're just going to transpose that, and we'll get our next stage. So when I bring this over, it becomes a plus. So I will subtract this from that, and I get this. Now we set our years from 2000 to this is 11 years. So where the x is, we're going to put in 11. So I go 3,500 times 11, add it to this, and actually I end up exactly with 81,000. Wow. Now an interesting thing, theoretically, at our zero value here, this should be our y-intercept, and it's close, but when we did it in this formula, we got this. So that's not super accurate. That's why I say this graph, if we were to graph it, would probably, look like that, where we could sort of get a line, but it wouldn't be a really super straight line, but it's sort of linear. Okay. Now I started this a little in number 18. Here they're giving us this formula. They're telling us the Fahrenheit reading, which is this, and they want us to find the Celsius. So we're solving for this letter C. Well, the first thing we're going to do is subtract 32 from both sides, or just transpose it. And I get this. So I've gotten the C term isolated on this side. Now how do I get it just to be a 1C? Well, I'm going to use the reciprocal, 5/9, and then I just multiply this side by 5/9. So take your calculator, multiply 5 times this, and divide by 9. On this side, these just all cancel out. And we get approximately letter C here. Okay, let's go on. We're almost finished here to number 19. Here we have photocopies that if we rent, I guess we're setting this up as equations here. So it's going to be 160 plus 10 cents a copy. X is the number of copies. And it's going to be 360 at 5 cents a copy. Okay. Now, a little problem here. There should be a point there. It's 10 cents because this is dollars, and this has to be Now we're good. So 5 cents a copy, and we're looking for a point where they'll start to get higher. Okay, so let's solve this by subtracting this from both sides. So we get over here. And we're going to subtract this from both sides, and we get 200. And now we just divide both sides by 0.05. And we get x equals 4,000. So there's our answer. Now the little tricky part here was that this is 10 cents, this is dollars, this was dollars, this is 5 cents. And it comes out nicely. Okay, now this last one was a little tricky too, because I'm not sure how they wanted the answer. And they gave us this inequalities sort of stuff. And what do we have here? Well, as I looked at this one, again, I'm not too familiar, I haven't taught it lately as to what they're asking, but they're saying these are the factored forms that are greater than 0. So we solve these when they're in their factored form by equaling each of the factors to 0. So these are the answers that we get. But since it's greater than, in a sense, these are not included in the set. And if you put them on a number line, it's that these are greater than 0, so that when you look at this from negative infinity, this is not an answer. Negative infinity is not an answer. So it's sort of like filling it in this way here. And this might be an answer, but it doesn't include these. So the answer they give in the book is this one. And as I look and study this is, if they gave me the choice, would be the one I would pick. But again, it depends on the lesson that's being taught. And again, this is just a typical test. There's lots of items that you've been exposed to. They're picking out some to give you the challenge of what do you know and what have you learned and what can you synthesize and be creative to get answers. Well, again, hopefully this is helpful, and good luck on your Chapter 2 test.